5 common scale applications. Just over 14 feet long. 14 feet long. This scale model is 1/24th size. 1/24th size scale. How do you know? Because on the box it says 1/24th scale. And what you just saw was a race car, 1/24th scale size, and it's just a little over 14 feet long. And we had the scale, we had the vehicle that we measured, and with that we were able to put an application to the scale and get a feel for it. Today what we're going to do is look at 5 different scale applications. We're going to look at the mechanical scale, we're going to look at the decimal scale, the civil engineer scale, the architectural scale, and the metric millimeter scale. And we're going to get a chance to look at all of these and see how they apply to both mechanical design applications and also other applications that we use in our different technologies. First thing we want to do is we want to be able to identify these scales. So to identify these scales, we'll pull up an application here, and we'll identify all 5, and the 5 that we're going to identify with are here, and those 5 scales are: number 1, a mechanical engineer scale; number 2, a decimal inch scale; number 3, civil engineer scale; number 4, an architectural scale or an architect scale; and number 5, the world standard scale, that scale being the metric millimeter scale or the System International metric scale. We can take it, divide it into 1,000 equal units, and we'll work in multiples of 1 millimeter. Now these scales are very useful and very important when we work with computer-aided design, when we work with computer-aided manufacturing, when we work in the area of quality, and everyone who works in design in particular should have a very strong background on all 5. The 3 that we probably use the most we'll look at toward the end of our discussion, but in this particular discussion we want to be able to look at a scale and identify which one of the 5 categories it falls into. So, mechanical engineer scale, that's a scale always in multiples of 16. So we work in units of inch, and that's the only units we work with, and we always work in multiples of 16. The mechanical scale might look something like this. This was a free scale, and we get it a mechanical scale because everything here is broken down into multiples of the mechanical unit. And you can see the mechanical scale, and you can see on the back side we've got metric scale. On the front side we got a 16 mechanical scale. Mechanical scale usually means fractional units or fractions. So that's our mechanical scale. Next we've got our decimal inch scale. And the decimal inch scale that we're seeing here is broken down into units of the decimals of an inch. We have 50 marks in 1 inch. We have 100 marks in 1 inch. If you take out your calculator, 1 divided by 50, the smallest mark becomes 0.02. And if we'd like to look at that, we can set it right here in our middle of our drawing here, and we can zoom in on it. There we are. And let's see if we can't even zoom in some more. Alright, here we have 0. You can see the 0 mark. There's 0.2, 0.4, 0.6, 0.8, and there's a 1/10 of an inch. So we got a 1/10 of an inch, 2/10, 4/10, 6/10, 8/10. There's 9/10 of an inch, 9.2, 9.4, 9.6, and the smallest unit before 1 inch is 0.98. 0.98. Now the reason we need to know the smallest unit is so we can always understand how we can discriminate the measurement. And the measurement here that we can discriminate to is 0.2. So 0.2 is our smallest discrimination when we have 50 marks or 50 units in 1 inch. So that's our decimal inch scale. And our decimal scale is always in decimals. We can take the unit divided by the number of marks, the unit divided by the number of marks, and we can come in then and work with two-place values, and two-place values are very common when we work with the decimal inch scales and the decimal inch measurements. Next, we'll take a gander here at the civil engineer scale. And the civil engineer scale is multiples of 10, and that means with the civil engineer scale we can have 10 marks in 1 inch, we can have 20 marks, we can have 30 marks, and we always associate back to 1 inch. And the marks, we could have 60 marks or 60 units in an inch. It could be 60 miles in 1 inch, could be 20 yards in 1 inch, and basically we can work in feet, inches, miles, rods, or any units that are divisible in multiples of 10, 20, 30, 40, 50, and so on. Civil engineer scale, take a look and see if we can find 60. There we have 60. Let's just kind of look at it. Let's compare it with our inch. Here's our inch. And here you can see, as we come in, 1 inch. There's 1 inch. And we've got 40 marks, 45, 50, 55, and 60 marks. So 0 to 60, we've got 60 marks all in 1 inch. So this is the civil engineer scale. You can see basically how we identify it, how we use it. And the civil engineer scale is very common for large displacements of length, and that's the reason for the civil engineer scale. Now we've got another scale that we look at, and that of course is our architectural scale. And we've got the architectural scale here. Come on out on it. And the architectural scale is one of these scales that's always broken down into multiples of feet and inches. So we have feet, we have inches. We have 12 marks, 24, 48, 96, and so forth. And with this, you can see that we can take any architectural scale, put it to an application, make a measurement, and let's just look at two of these. We'll look at the ½ inch will always be equal to feet, so we work with 2 units in architecture, inches and feet, inches and feet. And the two that we'll look at here is ½ inch equals a foot, and 1/8 inch equals a foot. And you'll notice that with the ½ inch equals a foot, we have a total of 24 marks. So let's go in there and check those 24 marks. There we go. ½ inch, this represents a foot. So 2, 4, 6, 6 and 6 are 12, so we got 12 marks here, 12 marks here. Total of 24 marks. That means the smallest mark then is a ½ inch on the discrimination. So from here to here, we got a ½ inch discrimination. So 1/2 inch equals 24 marks. That is a foot, and that foot can discriminate all the way down to 1/2 inch. So the smallest discrimination on that scale that we can discriminate to is a ½ inch. Now let's look at this other scale. 1/8 inch equals a foot, so there's our foot. There's 6 inches. There's 3 little marks, so we got 2 inches, 4 inches, 6 inches, 8 inches, and 10 inches. So the smallest discrimination on this, 2 inches. 2 inches is the smallest discrimination for the 1/8 equals a foot. This then gives you an idea of how the architectural scale works, what it looks like, and how we might use it in different applications. We've got one more scale we work with in mechanical design, and it's a very, very common scale. It's a scale of units in millimeters. So if we took the meter stick, approximately 39 inches long, take that meter stick, break it into 1,000 equal parts, and we'll get a very small unit known as a millimeter. And a millimeter is very small in nature. And if we take a look at the millimeter, we'll see that the millimeter might look something like this. And here we've got 10 millimeters, here we've got 50 millimeters, and here we've got 100 millimeters. And the millimeters are the common measurements that we work with when we measure things using metric measure. We're going to actually take a look at an object here, put it to some use with millimeters because it's very, very easy to measure and work with. We'll come on in like this, and we'll put this down here, and now we'll zoom in on this. And we want to look at this part because this is a computer part. It's extremely small and fine and delicate. And you'll notice that this computer part has got a small little feature down in here with some holes for the wires. There, I think you can see it. A wire actually goes through this particular feature right here, this hole, and wraps through on that little slotted feature. And this is a part here that we use in all of our computers. It's got a stamped stainless steel base. It's got a long flexure beam here, and it's got another piece out here that's laser welded to the flexure beam. And we're looking at a distance of 21 millimeters. You can see the small wire captures. You can see the hole approximately less than 2 millimeters in diameter. You can see the small hole here that's about 0.8 of 1 millimeter. And you get a feel for how big a millimeter is. And the millimeter measurement that we use, this millimeter measurement is the measurement that we use in a lot of our mechanical design applications. This then gives you an idea of the 5 common scale applications. Mechanical engineers, multiples of 16, decimals of an inch, multiples of 10, multiples of 50, multiples of 100. Civil engineers scale, we work with many units, inches, miles, rods, feet, and so forth. And then finally the metric scale. Now these 5 scales, these 5 common scales, excuse me, are typical of what we use in mechanical design. And these 5 scales give you and give me a real good feel for the types of engineering that we work with. Now, we're going to take each one individually and put it to a direct application, and to do that, we'll start with this very first one, put it to an application, and this very first scale, of course, is our mechanical scale. And you have this handout, and so I'm not going to spend a lot of time focusing on it, but I'm just going to hit on all 3 areas and do it rather quickly here so that we get an opportunity to examine in more detail some more specificity on scales. But this is the mechanical engineer scale divisible by 16. That means we got a full size multiple of 16. If we look here, you can see we're divisible by units of 16. So there's our mechanical scale. The smallest unit always lets you know what you're discriminating to. In this case, I can read to a 1/16 of an inch. So there's a 1/16 of an inch. Got another mechanical scale here, and this mechanical scale says 3/8 of an inch is equal to an inch, 1/2 inch is equal to an inch, and you can see the values that we have here, and with the 3/8 I can count up these small little units, and immediately I see 2, 4, 8, 8, and 8 more are 16, so I got 16 little marks. So the smallest discrimination is a 1/16. Here I've got 2, 4, 8, and 8 more are 16, and so the smallest discrimination is a 1/16. The nice thing that we have with this kind of a scale is it always says size, and anytime it says size is affiliated with the mechanical scale, because inches are always in inches, and so therefore we got 3/8 of an inch equals 1 inch, 1/2 inch equals 1 inch, and we're always dealing in multiples of size. So common unit, half size, there it is, half size. Another one, quarter size, 3/8 size. Now it says 1/8. There's a 1/8 size we could use, but there's also a 3/8 size we could use. And so you can see some of the more common applications for the mechanical scale, and we use the mechanical scale in mechanical design applications, and we use it in manufacturing technology applications. Now let's go to the next one, the decimal inch scale. Now the decimal inch scale is this scale that we've got here, and the decimal inch scale that we have, this comes right off of a drafting machine, and oftentimes to do a preliminary layout we use a drafting machine. It's not as common as it was 5 years ago, but there's still some old timers out there still using those drafting machines, and those drafting machines get us a feel for size. And so what we have with the decimal scale is we have multiples of 10, multiples of 50, or multiples of 100. And you can see if we have 100 units, we'd have 0.01. If we have 50 units, we'd have 1/50th. If you put that in your calculator, comes out 0.02. If we have, say, a half size scale and multiples of 10, and we'd have tenths. So tenths, 50ths, hundredths, these are all common decimals of an inch. And we're going to zoom in on this for our decimal scale, and we're going to try to make some checks. There we go. And you can see right here we've got 0, and we've got 2, 4, 6, 8, and we've got a tenth of an inch, 2 tenths, 3 tenths, 4 tenths, 8 tenths, 9 tenths, 9/2, 9/4, 9/6, and the last mark before 1 inch, 0.98. 0.98. So there you can see the units, there you can see how we make those measurements, and this is typical of what we work with when we work with a decimal inch scale. Decimal inch scales, common in mechanical design, common in the machine shop and manufacturing, and now we'll go to the civil scale. Civil engineer scale, we use the civil engineer scale for working with maps and working with geography and working with a lot of different, to get from here to there. And we can use various scales. We can say that 10 marks might be a yard. We can say that 30 marks might be a mile. We can say that 60 marks might be some other unit. For example, in surveying, 60 rods. So basically, that's what we have. A rod, if you look, is about 16.5 feet according to a surveyor. Civil engineers, we'll just take a look at 60 here if we can find it. There's 40, there's 60, and we'll zoom in on 60. There's 60. And let me just pull out an inch scale here, and I'll use this inch scale, and we'll put the inch scale here, and there you can see we've got 40, we've got 50, we've got 60. So there's 60 marks in 1 inch, and the 60 marks in 1 inch give us the complete representation of a civil engineer's scale. So on a map, we might have these 60 marks representing 60 miles. Actually, 1 inch is 60 miles. So there we go. That's our civil engineers. Besides survey work and mapping, we use it a lot for structural design applications with large superstructures. You might have a bridge, or you might have some large type of superstructure. Next, we get into the architectural scale. Always divisible by 12 inches. If we have 24 marks, well, then we can discriminate to a half an inch. If we got 48 marks, we can probably discriminate all the way down to a quarter of an inch. But we got 12, 24, 48, 96, and so on. The two we're going to look at are ½ inch equals a foot, and 1/8 inch equals a foot. And I've got both of those here. Here we go. And the architectural scale, as you can see, is 2 units, feet and inches. So there's our inches, there's our feet. ½ inch equals a foot. 1/8 of an inch equals a foot. And with this particular application, we've got a ½ an inch. It represents a foot. There are 24 marks here. And those 24 marks mean that the smallest discrimination on this is 1/2 inch discrimination. So I can discriminate on this architectural scale to a ½ an inch. I can discriminate on this architectural scale 1/8, and I count up the marks, and there's 6 little marks. That means the smallest mark, let's take a look at that. There they are. We've got 2, 4, 6, 8, 10, 12. So we got 6 marks that represent a foot. 1/8 of an inch equals a foot. And the smallest discrimination then is 1 mark, and that is 2 inches. So 2 inches is our smallest discrimination. And with 1/8 equals a foot, we've got those 6 marks, the smallest 2 inches. And our last scale here. Our last scale of measurement. We're going to look at the metric scale. And the metric scale is broken down always in ratios. 1 to 1, that would be full size. 1 to 2, 1 to 10, 1 to 100. What we're doing here is this is half size. And we use ratios to write the value in terms of the scale sizes, and then all we do is basically move the decimal point. But in this particular case, in mechanical design, we'll work 1 to 1, and we'll look at 1 millimeter, 5 millimeters, 10, 15, and 20, and here we have 50, and over here 90 millimeters, 91, and you can see the millimeter is a very comfortable measurement to work with. And we're going to take a part here, I'm going to put it on here, and we're going to make a millimeter measurement on this part. This happens to be a part for a computer. There, we'll zero in on it. That's as much as it zeroes in, so that tells you how good our camera is, right? Okay. And you'll notice that this part is 21 millimeters long. 21 millimeters long. So I'm going to leave this set here. Oh, by golly. Don't mess with it, right? Okay. There's our 21 millimeters. You can see we start over here and we go to 10 millimeters, we go to 20, and we go to 21 millimeters. So 21 millimeters on the length of this part. You can see the hole or the feature that we have here is about 2 millimeters or less. This small hole is for a wire, and that wire is 8/10 of 1 millimeter. So you can see here's a millimeter. We're about 8/10 of a millimeter, and there's even some smaller slots and so forth here, and some smaller geometry for this. But this part right here is a computer part. In every computer you purchase, there's one of these on the hard drives, and this is a stainless steel stamping, and this is a photo etched part, and this is a photo etched part. And basically what you're looking at is a millimeter measurement for a computer part. Well, that pretty well gives you a background on how you read the scales, and you can go through these readings, and you can study these readings. We can probably take our scales and we can probably break them down into 3 that are very common and extensive in the area of manufacturing. And the 3 that are common and extensively used are here on the screen. And we'll zoom out on this. And they are more or less a type of steel rule. I've got one here for you. And the steel rule I've got is this steel rule. And you've got fractional units on this steel rule. You turn it over and you got some more fractional units. But basically, if you look at it, we've got multiples of 64, multiples of 32nd, and 32nd here and 64 here are basically what we've got here on this drawing. And so here you see the 32nd, here you see the 64, and here you see how you'd read these. We call this a mechanical scale because it's a type of engineer scale, multiples of 16. Very common scale that we read. When we start over here at the small unit, we go over and we can see the discrimination to a 32nd. Here, 64, we can see the discrimination to a 64ths. Next, we got our decimal scale, common steel scale, multiples of 10, so we read it 0.10, 0.40, 0.60. The reason we use 2-place decimals is because it becomes significant when you're working with a casting or a fillet. If you've got a 32nd of an inch, we just round it off to 0.3. So therefore, it is significant. We work with 2-place decimals, 2-place decimals, 2-place decimals, 2-place decimals, 2-place decimals, and this is our common decimal scale. The last scale in manufacturing that we run into quite extensively, you saw it with the piece part just a minute ago, and with this piece part here, we got a 1/2 millimeter to discriminate, so a 0.5 on the 1/2 millimeter, 1 millimeter, 2 millimeters, 5 millimeters, 10 millimeters, 9.5 millimeters. If you practice working with these scales, you'll do it right every time. I would like to encourage you to do as much as possible with reading these scales, studying these scales, doing exercises with matching, where you take and you look at this and you look at that and you kind of match it and see if you can understand what you have. I want to wish you good luck on reading scales, and it's a very important part of what we do. And the last thing you want to do when you work with your scales is study the scale sizes. The scale sizes, for example, on a 1/8 inch equals a foot, you take the 1/8 value, you multiply it by the reciprocal of a foot, which is 1/12, and we get 1/96 size. In closing, the scale that you saw in the beginning of this presentation was a 1/24 size scale, and here it is, 1/24 size. It was 1/2 inch equals a foot, and the 1/24 size gave us the 14 feet on the length of our race car.